Welcome to this explainer. India is on the verge of making a massive leap in green transit with its very first hydrogen-powered passenger train. But beyond all the headlines and the hype, what is the actual data-rich reality behind this launch? Let's dive right in. Here is what we're looking at today. First up, launching the Namo Green Rail. Then we'll check out the tech specs and innovations, see exactly how hydrogen fuel works, dig into the supply chain reality, break down the costs and future expansion, and finally, do a bit of a strategic reevaluation.
All right, part one, launching the Namo Green Rail.
To set the stage here, Prime Minister Narendra Modi is expected to inaugurate this groundbreaking pilot project on July 17, 2026. And look, this isn't just another train hitting the tracks. It officially marks India's entry into a very elite, very small club of nations. We're talking Germany, Japan, China, and the US that are actually utilizing hydrogen for clean transport. The train itself is going to operate under Northern Railways, running its pilot on the Jind to Sonipat corridor over in Haryana. Now, why this route? Well, because it's a non-electrified line, it is literally the perfect real-world testing ground to replace dirty diesel without needing to put up all those overhead wires. To support the whole thing, Indian Railways has actually built a dedicated indigenous hydrogen refueling facility right there in Jind. When it comes to daily operations, this thing will cover a massive 356 kilometers. It's scheduled to knock out two 89-kilometer round trips every single day. That kind of mileage is deliberately designed to thoroughly test the technology under real-world, heavy passenger conditions, assessing everything from basic acceleration to emergency braking. Moving on to Section 2, Tech Specs and Innovations. Honestly, the sheer scale of what Indian engineers have put on the tracks here is incredible. We are looking at the world's longest and most powerful hydrogen train ever built on a broad gauge system. You've got a 10-coach train set that's 2 driving power cars and 8 passenger coaches, and it's pushed by a massive 2,400 kilowatts of total power, which is roughly 3,200 horsepower. It's designed to carry up to 2,600 passengers per trip with a commercial speed of 75 kilometers per hour, though it has already hit up to 120 during testing. To keep a giant like this moving, it stores 440 kilograms of compressed hydrogen across 54 cylinders, 27 at the front, 27 at the rear. That setup gives it a solid 250-kilometer range on a quick 20 to 25-minute refuel. It even uses regenerative braking, so it captures kinetic energy to recharge the onboard batteries. At full passenger load, it's going to consume about 300 kilograms of hydrogen daily. Okay, Section 3, how hydrogen fuel works. So, how does this actually work without burning traditional diesel? The real secret sauce here is the hydrogen fuel cell. Instead of burning fuel to create propulsion, this train basically acts as a rolling power plant. It produces its own electricity entirely on board through an electrochemical reaction, completely eliminating the need for fossil fuel combustion. It is such an elegant 3-step process. First off, hydrogen from those roof tanks is fed into the fuel cell, where it combines with oxygen drawn right out of the outside air. Second, this chemical reaction generates the electricity needed to drive the train's traction motors and power things like the air conditioning. And finally, the only byproduct of this entire process is just harmless water vapor and a little bit of heat. It's a true zero-carbon emission cycle. But there is a catch. Let's look at Section 4, the supply chain reality. We've really got a tale of 2 systems going on here. On the indigenous side, the capability is absolutely phenomenal. The train set was built by the Integral Coach Factory in Chennai, the complex system integration was handled by Hyderabad-based Meta servo drives, and the ground infrastructure in Jind is completely local. However, the imported core is where we see some vulnerability. The actual fuel cell stacks, the literal heart of the train, are supplied by Canada's Ballard Power Systems. Plus, the advanced materials inside them, like Nafion membranes and platinum catalysts, along with the carbon fiber tanks, heavily rely on foreign suppliers. And this dependency is a pretty crucial operational challenge. Relying on imported materials exposes India to global supply chain volatility. And that isn't just some hypothetical risk. Germany, which was an early pioneer in hydrogen rail, recently had to sideline a good chunk of its own fleet due to unexpected fuel cell degradation and some serious hydrogen supply reliability issues. Long-term success is definitely going to depend on establishing a reliable green hydrogen supply chain and domestic breakthroughs in material science. Let's talk money in Section 5, costs and future expansion. So what exactly does this technology cost to get off the ground? Well, the initial pilot project required a sanctioned investment of over 111 crore rupees. That covered retrofitting an existing diesel train and setting up the initial ground infrastructure. Moving forward, the capital expenditure for each new hydrogen train is estimated at about 80 crore rupees. But remember, you can't just buy the train. You need the infrastructure to actually support it. That requires an additional 70 crore rupees per route just for the necessary ground setups, like the electrolyzers and the refueling stations. Despite these pretty steep initial costs, Indian Railways has a really grand vision. Under their Hydrogen for Heritage initiative, they're planning a massive 2,800 crore rupee rollout of 35 additional hydrogen trains. The goal here is to deploy these on scenic and hilly heritage routes, where putting up traditional electrical lines would either be way too difficult or just visually disruptive. Which brings us to our final point, Section 6, a strategic reevaluation. Does all of this massive investment align with India's long-term strategy? Lalit Chandra Trivedi, the former GM of the East Central Railway, makes a very compelling point. He noted, and I quote, "India should carefully reevaluate large-scale deployment of hydrogen trains in the present context. With Indian Railways having achieved near 100% broad-gauge electrification, renewable energy can be directly fed into the traction network, offering a more efficient and economical pathway." It's a really solid point. If you already have the grid, why not just feed renewable electricity straight into the overhead wires rather than relying on complex imported hydrogen systems? So it leaves us with a profound strategic question. As India pushes toward its net zero emissions goal by 2030, will these highly innovative hydrogen trains become a cornerstone of the network, or will traditional electrification, powered directly by renewables, reign supreme? Only time and the results of this Jind Sonipat pilot will tell. Like, share, and subscribe the channel for more videos. Thanks for watching EIA Practitioner.